it does all the testing. So it checks CPU subsystem, it checks CPU, DRAM, and the portion of flash that makes up the file system. And then what happens after this? So once it tests that all the hardware associated with the switch is okay, it loads a program called bootloader software. A bootloader software is a, you can consider it as a set line of code. It's a very small program that's again stored in ROM, which is run immediately after a successful post completion. What this bootloader software does, what it does, it performs the low level CPU initialization. CPU is a central processing unit. It has a physical memory, it has registers, it has the speed. So it tests all these very low level computation, that whether the CPU has initialized registers, which control of the physical memory would be mapped to, what memory of physical memory would be given to what resources, and what speed should be there. We can always change this configuration. We will learn about that. So all these initial level configuration that are stored in the bootloader software, they are performed in the step 3. So once it is done, the bootloader initializes the flash file system on the system board. So it's sort of the same system that you have on the hard drive. So when you power on your computer, what you do is you mention that whether you want to initialize the system, say Linux, Windows operating system, different operating system you might have on your hard drive. So it also have that system initialized in its flash drive. So it boots from there. And finally, it locates and loads the default iOS operating system onto the software image, so and gives you control of that. So iOS is the inter-network operating system. It's the Cisco proprietary operating system, which is used for configuring switches and routers and other end devices as well. So once you have the control of the iOS system, you can work what you want to do, or you can also manipulate some of the configuration to get the required functionality done. So in nutshell, if I want to say, is that the sequence loader loads the iOS onto the device and makes a smooth transition from the mapping of, say, kernel to the user based system. So now once the system is loaded, you can do your reconfiguration. You can use the initial configuration set. You can do whatever you want to have the underlying network functionalities taken from it. The next is the boot system command. So the switch attempts to automatically boot the information from boot environment. If you do not specify anything, if nothing is set, it attempts to load and execute very first executable command that is found, that it finds. So it has one configuration file called startup config. You can also call it config.txt. So it's the file that is loaded on the start of your interface. So once the iOS operating system initializes the interface, it looks for this startup configuration file, and it executes the commands that are listed in the startup configuration file. What basically happens in that is it has the structure as shown on your screen. So it has the boot system, flash, and as well as the iOS file name. So the very first command is the boot system. It's the main command to load your, so where to load your image from. And then the second is, you mentioned the storage device. So flash is the storage device. You mentioned that we will be taking the input image from the flash. This one is the path. A K9 represent that it has cryptographic functionality involved in it. We will learn about that in a bit more detail. And then finally, this one, the last appended unit with ending with .pin, is the image file. So in here, you just mentioned the path from where you the system would load the flash. Sorry, the system would load the iOS image from. It again has, so one is startup configuration file, one is running configuration. So once it is loaded, once you make your changes in the configuration file, it is stored temporarily in the running configuration. And then if you are happy with those changes, you could copy those running configuration in the startup configuration that you might have already done in the CE155. So what happens initially once you turn on? I do not have access to the physical switch here, otherwise I would show you. If you have attended CE155, you might have in the labs seen this physical switch. So if you remember correctly, it has these this sort of interface. It has again a large number of ports in which you can put your Ethernet cable, some other cables. This is basically the LED indicators that it has. So once you power on, it has 1, 2, 3, 4, 5, 6. So this, we are basically talking about the CE2960 switch or the similar family switch. So what is this syst? So this is system LED. It shows whether the system is receiving power or functioning properly. So when you switch on, it should be green. We'll learn more about the colors in the next slide. But just let us just go over what each of those show or portray for. The second one is the RPS. It is redundant power supply. Some of the switches have it, some of the switches do not have it. But if a switch is having this, and if there is an alternate power supply source that is coming to the switch, in case the initial or the primary source fails, so it will be shown in the RPS indicator light. The third one is the stat. It's the port status LED. When it is green, it indicates the port status mode, which is the default. So it is associated with different ports. So you can't just see that it's green here. It will be green, but again,